Everyone. Welcome to C++ STL workshop. My name is Charles, and I'm a third year in computer science. I'm also the competitive programming chair, so I'll be talking a little bit about that before we get started. So before we start, can I just know what everyone's last CS class was? Like if you're taking 10B right now, you can just type 10B. If you finished the 10 series, then just type 10C, just to see what everyone's understanding is. Okay, so I'm seeing a lot of Bs, some As and Cs. It's mostly A's, I guess. Okay. All right, so let's get started. Can everyone see my screen? Yes, okay. So yeah, welcome. So what's competitive programming? You basically just do coding problems, kind of like interview problems from LeetCode, except they're kind of harder and they have tighter constraints and they're pretty strict as well. So, and in competitive programming, we learn a lot of data structures and algorithms as we do more problems and solve and participate in more contests. So our next meeting is this Saturday at Winston Chong 143. It's one of the classrooms on the outside. And we also have free pizza. So yeah, make sure to attend. It starts at 11 a.m. So competitive programming gets you ready for the ICPC, which is kind of like programming contests with other colleges. So these three people were qualifiers for the North America regionals this last year. So if you practice enough, you could, someday be able to go to regionals. These are some of the classes offered at UCR that teaches algorithms. So the blue ones are like mandatory classes for your degrees if you're a CS major. The green classes are some of the technical electives that you can take to learn more algorithms. And the yellow ones are graduate classes, but you can still take them as an undergrad. Yeah, some resources to get better at competitive programming is just practices at some of these websites like Codeforces. That's what we use. @Coder, CodeChef, Project Euler. Python for CP is by a graduate named Cyrus. CP Algorithms, I think it's a website, and there's a lot more websites. Yeah, So does anyone have any questions so far? Oh, okay. So what if you're a freshman and you're not a CS major, maybe you're a transfer student, should you still do this? Yeah, the answer is yes. You definitely should try it out and see what it's like. Then you can decide for yourself. It's also really good practice for coding interviews and technical interviews. I don't think I'm smart enough, talented enough. Yeah, in the beginning, I thought of this too, but you just got to keep practicing and eventually you'll get better. Just need to keep practicing and learning. So yeah, that's how you improve as well. I don't enjoy this. Should I look for something else? Yeah, you definitely should. If you really don't like competitive programming, then you should just, find something else to do, like maybe go into game dev or cyber or something else. So let's get started on the STL library. So what is C++ STL? It's like the standard template library that the developers made. They give you some classes and functions that are already implemented. And most of them are very, very useful for the language. And you might have heard of cout vector, maybe sort function, and some other data structures like sets and maps, which we are going to talk about today. And you also get to solve problems that seem very hard with ease. Does anyone have any questions so far? Oh, okay. Okay, so I'm going to share my screen and do a live demo on some of the code for the STL. Okay. Okay, so we'll get started with vectors and algorithms. So first, in C++, you got to include your libraries. And I commented this library out so that, you only use this for competitive programming because this includes like hundreds of libraries in C++. So it's very bad for compile time. So never use this for real life projects, but you can use this for competitive programming. So it saves you all the hassle of writing these, So we're gonna get started on vectors and algorithm class library. So who doesn't know what a vector is? If you can just type in chat, there's no shame and if you don't know. So a vector is just an array, and it's dynamically allocated array. So like you can adjust its size, and you can also have other functions with it. Yeah, vectors are array lists in Java. Yeah, very similar. So to initiate a vector, you can just type vector in the data type v, and then this number right here too is the size, and you can also add another parameter, which is assigns every single element to this value. So, okay, wait. If you guys want to follow along, then I can also send this code to the chat. Okay. Pushback is another function which just inserts elements to the back of the array. So the runtime is very fast, constant. So O of 1. So as you can see in this array, I already have 3, 3, and then I add 5 to the back, 1, 1, 3, 7. So the array is unsorted, right? It doesn't go from smallest to biggest. So right here, this is the terminal. I printed out unsorted. The array looks like 3, 3, 5, 1, 1, 3, 7. And then there's a sort function in the algorithm library. It's called sort. So the parameters are the beginning and the end. So you have to type variable name dot begin and then variable name dot end. And we'll talk about what these are right after. So this just sorts the vector from the beginning to the end automatically in n log n time, which is the fastest sorting time. So as you can see, after I sort the array, I print it out, it's sorted. So yeah. So let's talk about the iterators. So dot begin and dot end are called iterators, or kind of pointers in the library. They point to the elements. in the vector. So they're kind of like indices. Like they're kind of like int I in the for loop, except not really. They're a different data type called similar to pointers, but they're just called iterators. And to initialize an iterator, it's kind of annoying because you just have to type vector int : iterator. Then you can get the iterator element. Or you can use auto. So it's very useful to like initialize these annoying data types. So what do you mean by points? So for example, v.begin does not point to, is not the value 1. v.begin is not 1. v.begin is a data that points to 1. So it has the address of 1. Does that make sense, Sachin? Oh yeah, so
yeah, it makes sense.
Okay, cool. Okay, where's O and where did this say that? Oh, so are you talking about this? Okay, so runtime. In computer science, we're very strict on runtime. We have to like, so that things can run faster. So O of 1 just means inserting this element takes constant time. So it just inserts very fast. You don't have to traverse through an array to insert it. You just straight up insert it. So for example, if you want to traverse through the array and print everything out like this, it would take O of n time. It just means you have to process n elements in order to get this job done. So to print out n elements, the runtime is O of n. As for the sort function, you need to sort n elements. The runtime for that is n elements times log n. It's kind of hard to explain why. So you'll learn it in CS 10C. Yeah. So v.size is just the length of the vector. Yeah. Okay, so here's the demonstration. So iterator 1, it1 points to the beginning, so does it2. So right here, I printed it out. So v.begin will point to 1. So this star thing right here, this asterisk, dereferences the pointer. So it gives you the value that it's pointing to. So remember how it1 is a data that's pointing to 1? It1 is not actually 1. It's something that's pointing to 1. So to get that first element, you have to dereference it. So you star it1. Star just grabs the value that it is pointing to. So it will point to 1. And so it printed 1. v.n is another iterator. But the thing is, it doesn't point to the last element. It actually points to the element after the last element. So if I can annotate, so let's just say we have an array like, oops. Okay, so v.begin will point to this. So this is an iterator equals v.begin. The iterator is not 1. The iterator is the thing that's pointing to 1. If you do v.end, it's going to point to this empty space right after. So it's probably some garbage value that you don't need to care about. So when you call the sort function, it'll sort from begin to end, right? Sort from here to here. So in this demonstration right here, v dot end, when I print out v dot end, the dereferenced value of v dot n, it printed out 0. And we don't have 0 in our element, in our array, right? So if you look at this vector right here, we don't have a 0 in there. So what you need to do is do v dot n minus 1. So it grabs the value, the last value, and then you do reference it. So v dot n minus 1 will point to 5. Or in this case, the last element is 7, so it's pointing to 7. So that concludes the iterator part of the STL. Does anyone have any questions so far? Anything unclear? Okay. So what if?
Hold on. One question.
Yeah.
What is that -1 for?
So the -1 will bring the iterator to the element before. So let me annotate. So for example, so v dot n, like I said, it points to the empty element, like right here. There's nothing here.
Okay.
Like it's null. But if you do -1, it will go right here. So it will go to 5, which is the last element in this array, in this vector. Yeah.
Okay, gotcha.
That's how they implemented it. So what if we don't put -1? It points to what? It will point to nothing. It will point to a thing called null pointer, I think, or some random garbage value. What does v dot begin +1 do? So if you do at +1, it will point to the second element. So it's kind of like int I equals 0 in the for loop for a normal array, a vector or array. Right. Oh yeah. I'll talk about how to iterate a for loop with iterators. You don't really use iterators for vectors. You only use them for other data structures that I'm gonna like sets and maps. If I have time, I'll talk about them. Okay. Any more questions? These are great questions, by the way. Okay, so we'll move on to something a little bit fancy, I guess. Let's make clear drawing. So there's a thing called lower bound and upper bound. And what they do is it's like a search function. It searches a sorted list. So a sorted vector, a sorted list, or something sorted, So it goes from lowest to highest, or something that's sorted in however way you want, and it will find it in log n time. It uses binary search. So has anyone not heard of binary search? Does everyone know what a binary search is? Okay, so a binary search is, so for example, I want to search for the number 5. I want to search for 5. If you do a linear search, that means you have to traverse through every single array, every single element to find the number 5. So I have to go 1, 2, 3, 4, 5, 6. So then I find the number 5. So the worst case, if I want to find 7, the worst case would be, it has to traverse through the whole thing. So that makes it of n, right? Because you have to traverse n elements at most. So that's the worst case. So that's why linear search is very slow if you just want to search something. There's another way to search. It's called binary search. For example, I want to search for number 5. What I would do is have the array. This only works on sorted arrays, by the way, assorted data structures. So it needs to go from lowest to highest. So what it do is start in the middle. So like here, is 3 less than 5? Yes, it is less than 5. So I will search in this area. And then it'll take the middle. Let's just take the left side. Is 3 less than 5? Yes. Search the right side, so like this. And then I'll take 5. Is 5 5? Yes, it's 5. So we found it, right? And that only took 3 steps. So if you expand this to like a bigger array, let's just do something a little bit bigger. Okay, so, does Sachin have a question?
Yeah, so do binary search trees only work if the items are in numerical order?
It has to be from lowest to highest or highest to lowest. It doesn't have to be integers. It can also be like strings, but you just need to have some sort of system that can compare. You can compare.
I see. So they have to be sorted first.
Yes, they always have to be sorted in order for binary search to happen.
Okay, got it.
Yeah. So if you want to search for, I don't know, 3, you start in the middle. So in the middle is like 6. You limit your range to the left side because 6 is greater than 3. And then you search this area. And you go to the middle. The middle, let's just say it's 4. 4 is greater than 3 still, so I will limit the range to here. Actually, in the middle is 3, but yeah. So as you can see, the search range halves by every time, every iteration. So the search range became 11, and then it became 6, and then it became 3, right? And then if you keep doing it, it'll become 2, and then become 1. So this decreases by half every time, right? So there's like 5-ish kind of operations. So it's definitely not n elements. It doesn't traverse through n elements, right? So it actually traverses through log n elements because it's decreasing at an exponential rate. The search range is decreasing at an exponential rate. So yeah, how would it work for strings? Oh wait, let's answer Adele's question first. So if it's even, then you just simply take, and it's based off of your implementation. It just takes 2. It takes like the left, it can't be here, right? It'll just take 2. If you have, let's just take 3, you can take the right side if you want, but that's depends on how you want to implement it. How would it work for strings? So strings are ordered like A, A, B, C, and then A, C, B goes. So it's kind of like, A is smallest, B is biggest, Z is the biggest, something like that. I think, I'm not too sure on if it'll count the characters first or alphabetical order. So what I'm trying to say for binary search is very fast. It's faster than linear search, right? So in this example, we're gonna do lower bound and upper bound. Lower bound is a binary search function. And the searching method is kind of hard. I mean, it uses binary search. It's a little bit weird. So, okay. So if I do lower bound, right? If I do lower bound 3, oh yeah. So how you write it is v.begin, v.end, just like this is your search range. It's just like the sort function. And then the third parameter is the value you want to search for. So, and what it's going to return is the pointer or iterator that points to 3. So lower bound will point to the, okay, I need, lower bound points to the first value that's greater than or equal to 3. So lower bound 3 will point to the first value that's equal or greater than 3. So point here. And if I do lower bound 4, 4 doesn't exist, right? So the first value that's greater than or equal to 4 is which one? Does anyone know? Okay, 5. Yeah, that's correct. So lower bound will find this pointer at log n runtime. So, you know, instead of searching linearly like 1, 2, 3, or 1, 2, 3, 4, 5, 6 to 5, it'll search it in like 2 to 3 operations. Since log of n is going to be like 7 or 8 in this case. It's going to be like take like 3 operations instead of 8 operations at the worst case. So this is really useful for a particular example. So let's go over upper bound. It's very similar to lower bound. Upper bound will return the iterator that points to the first value strictly greater than a. So lower bound is equal to a or greater, upper bound is strictly greater than a. So that means if I do 3, what is it going to give me? Where is it going to point? Does anyone know? Yeah, it will point to 5 because 3 is not strictly greater than 3, so it will point to 5. Nice. What about upper 4? Oh yeah, these are all like, you know, printed on the terminal. By the way, so I'll do another example. What would this point to? This will point to 5, by the way, because 5 is greater than 4. What does upper 7 point to? This is kind of tricky. Yeah, that's right. It'll point to null because 7 is not strictly greater than 7. So it points to the thing after 7, which is, you know, null pointer. So this method, this upper bound, lower bound is very useful for searching a sorted list. And a particular common question or common way to use this is to count how many values, the same values in a sorted list. So in this array, I have 1, 1, 3, 3, 3. Let's add another one. 5, 7, and then we got like the null pointer, right? So if I want to find how many number of 3s are there in this list, if you didn't know about binary search or upper bound, lower bound, you would first think, maybe I need to find the first three, right? And then I need to find the last three, the three that's right before 5, right? So how do I do this with lower bound, upper bound? Does anyone want to take a guess? Not sure. Okay. Well, so, if you do a linear search, you would do, if you do a linear search, you would find the first 3, right? And you also find the last 3. And you kind of like, if you had indices like, 0, 1, 2, 3, 4, 5, 6, 7, right? You would subtract 2 and use 5 from 2 and then you plus 1 because you don't want to like miss the first element from counting. So obviously there are 4 3s, right? You just do 5 minus 2 plus 1. You get 4. But with lower bound, upper bound finds the first number that appears that is greater or equal to. So lower bound 3 is the first number that's equal to 3. So it will point right here. If you do upper bound 3, it will not return the last 3, it will return 5, right? The pointer that points to 5. And what you can do is you just do upper bound 3 minus lower bound 3. And this will just straight up give you 4. Let's test out the code. So right here, I did iterator 5 minus iterator 3. Notice I did not dereference it because I'm not subtracting 5 from 3. I'm not doing 5 minus 3. I'm doing position minus position. So the fifth, the position that holds 5 minus position that holds 3. So it's kind of like 5 minus 2 plus 1. But in this case, we use the iterators to find out how many 3s there are in this vector. So let me see, actually. So there are 1, 2, 3 3s in this vector. So if we run it again, yeah, so there number of 3s in the vector 3. So that's a really fast way to see how many vectors there are, how many 3s there are in this vector. And that concludes the algorithm part. We don't have a lot of time left, so let's go over sets real quick. Does anyone have any questions so far? Okay. Okay, so set is a data structure you probably did not learn yet. So what a set does is it's always ordered. So it's always sorted. If you insert anything, it's going to be sorted. There are no duplicates allowed, so everything's unique. Yeah, this is set by the way. So for example, right here, if you insert 2, what you will get after inserting 2, you will only have 1 2 in there. So it does not allow duplicates. It's also sorted. So wait, actually. Okay, so the erase function will remove elements from the set. So, right now I have a 2 in my set. If I do erase 1, nothing's going to happen. If I do erase 2, it's going to take 2 away, so my set's empty now. And then if I erase 2 again, nothing's going to happen. Yeah. So these are some basic functions. So to insert, you just type set.insert. To erase, you just do set.erase. Any questions so far? So unlike the vector, set does not have, you cannot access elements with like an index I, right? You can't do for int I equals 0, blah, blah, blah. So instead, you're going to have to use iterators. So you start from the beginning. So this is kind of like I equals 0. And it does not equal to set.n. It's kind of like I is less than n, right? And then I plus plus is just it plus plus. So this is how you do a for loop with sets. And since it is an iterator, not the actual element, you're going to have to dereference it when you go through the for loop. Okay, so there's also the empty function. It just gives you a Boolean value of whether it's empty or not. It exists in every data structure class, including vector. So yeah, there's empty. So now we're going to insert more elements into the set. As you can see, we have nothing in our set right now. So if we insert 4, 2, 5, 3, 1, it's going to insert everything in an orderly manner. So set is always ordered, right? It will just automatically sort it for us. Notice I didn't type any sort functions, so it's always going to be ordered. Okay. Now to check if a number is in the set or not, we can just do count. So count just counts the number of items in the set. And it will always return 1 or 0 because sets, the numbers are unique. Elements are unique in the set. So it'll always return 0 or 1. So if I counted 3, which is in the set, it will return 1. So if I count 6, 6 is not in the set, right? I only inserted 1, 2, 3, 4, 5. So it's not in the set. It'll return 0. To actually access the element in a set, we have to use the find function. And the find function is pretty similar to the count function, but it actually returns an iterator this time instead of just like a status of 1 or 0. So you can kind of replace count with the find function if you want. So again, if you want to find 3, we want to find the iterator that points to 3. So 3 will exist and it will return an iterator to 3. If you want to find 6, 6 doesn't exist in the set, so it will return set.n. Set.n, everything, when the iterators.n is kind of like a null pointer. It's like a does not exist. It's kind of like it's kind of, it marks the end of a set. So whenever you see set.end, it's kind of like a 0. So, right, yeah. So that's how you find, get the iterator to the value. So what I covered with this for loop looks very long and annoying to type out, right? And if you don't really care about the iterator, there's a faster way to do it. You can type the enhanced for loop. You just do auto, you just do for data type of the element, not the iterator. So the element of this set, the data type of this set is int. So right here, I can type int to replace it. But if you forgot what data type you have, you can just type auto. E is the element. E can be anything you want. You can type O or P or whatever. But E is the actual element with the data type int. And then colon, st is the name of the data structure. Right here. So it's for basically saying for every element in set printed out, right? You just straight up print E. You don't dereference it. It's already an int. So that's how you do it with the enhanced for loop. If you just want to do a simple printing to debug your code. That's about it for sets. So does anyone have any questions on sets? And so to quickly review, they're unique. Every value is unique. They're always ordered, right? They're always unique. They're always ordered. Oh yeah, the runtime. Library needed for auto. No, auto is like a thing built in already for C++. I think you just need to like update your C++ if you want auto or something like that. Do sets work with strings? Yes, sets work with any data type. So if you do, if you do set dot insert, just say h hello, and then in the set it's going to be hello. If you insert again, hello, it's still going to stay like this. If you insert something else, then world is going to be in your set. And they're always going to be ordered. So world goes after hello because W is smaller or is bigger than H. The reason why we would use set is because the runtime is pretty fast, pretty reasonable for this kind of data structure. So almost everything in set is log n runtime. To insert something, it's always log n. So compared to vectors, okay, let's do insert, let's do delete and access. So vectors, insertion from the back. If it's from the back, pushback, it's O of 1 because it just adds the element to the back, right? For a set, it's going to be log n because it first needs to search to where to insert it. And since it's always sorted, right, it will search log n time. So when you insert it, it needs to search first and then insert. So it's going to be log n. And the search is a binary search. And since set is always sorted, right, inserting it is log n. All right, so deletion. If you want to delete from the back, it's O of 1. But if you want to delete the beginning, the front, it's actually O of n, because vectors are like, you know, if you delete 0, everything here has to shift. So you're shifting n elements, right? So this will take O of n time. But deleting in a set is also log n, because you need to find the element to delete and then remove it. To access, vectors are faster because you can just do, something like vi. This simply finds the element in O of 1 time. And to access for a set, it's also log n, because you need to search for the set to see if it's search the set to see if the element is in there or not. Yeah, that's about it for set. Anyone, any other questions? We're kind of running out of time, so sorry I couldn't cover maps. Maps are like more useful or more commonly used, I guess. But yeah, maps are very similar to set. It's just kind of like, you can think of it as a set, but the values in the set grants you access to another value. So maps are usually like, you have a key data type and you have a value. So you can think of it as, set with the key, but it grants you access to something else. So which is, yeah. And I can't cover that right now because we're running out of time, but if you take a look at the code I sent earlier, you can maybe learn from that. You can also learn from the website c++.com. Yeah, they have all the implementation and the documentation of these data structures. Okay. Does anyone have any questions? But yeah, that concludes the workshop for today. Hopefully this helps you for solving any sort of coding problems. Yeah, thanks for coming, everyone.